Welcome to single phase motors video part number 8. Today we are going to discuss about repulsion motor. We'll call it as basic repulsion motor because we'll be discussing about three types of repulsion motors. Basic one, repulsion start induction run motor. Next, repulsion induction motor. This is the first part, repulsion motor basic we attend. Let us see. We'll be first seeing the construction part. The construction of the stator, there are stator and rotor in a motor. The stator will be distributed non-salient pole type rotor. Oh, stator, what is that? Like this. Like a normal single phase induction motor like CSIR, CSCR motor, there will be a stator. This is the stator winding. And the rotor will be normally like a DC motor. As if in a DC motor, you will be seeing a DC motor. DC motor rotor. So this is the DC motor rotor. So the stator is like AC motor and the rotor is like DC motor. And you can see the pictures like this. There are two pictures. We'll be seeing the stator part. The stator pole N is shown, S is shown. Actually, this type of construction is known as salient. Then we told already it is actually distributed non-salient. Then in the picture we are just giving this type of projecting poles only for theory explanation. Okay, this is known as salient pole, but actually practically in repulsion motor it is not projecting pole, but it is distributed over the circle. The winding it is totally everywhere available. For reasons of explanation we are telling the type of projecting pole. About the rotor, you can see this is the rotor and rotor is like DC motor. There is armature type of construction and you will be able to see the brush which is in yellow color. And the thing is the brush is shorted in repulsion motor. The main difference. The brush is there, brushes are there and brushes are shorted. Okay, brushes are shorted. That is the main difference. So the rotor is not connected to outside. It is acting as a squirrel cage rotor. Actually it is a wound rotor. It is totally closed. The winding it is totally closed and it is connected through a brush shorting. Okay. Now you will be able to see the difference between two pictures here. What are the difference? The only difference is the brush shorting. Here the brush is shorted like this and in the right side picture brush is shorted like this. What is happening? We can see the magnetic axis like this. Magnetic axis means from N to S a line joining that. That is known as magnetic axis. And the brush shorting angle that is also in the same line. In the same line. Okay, that is known as collinear. Collinear. In the right side picture, this is the magnetic axis. And where is the brush shorting axis? The brush shorting axis, it is 90 degree to the magnetic axis. So these are the two differences. In the first picture, magnetic axis and brush shorting axis, it is collinear. In the same line means collinear. And the right side, the brush axis and this brush shorting axis is at 90 degrees to each other. What is the production of torque in repulsion motor? How it is rotating, that we are going to explain in this section. Let us see. N pole is available at top, that is right, and S pole is available at bottom, and brush is shorted. Brush is shorted collinear in the same line. So that is a collinear with magnetic axis. Magnetic axis may he in the magnetic axis only the brush is provided. And you can see the induced EMF is minus in one side and plus in other side. Okay, how to say about the polarity? This is the brush shorting axis, this side and this side, that is creating the induced EMF. In the right side all plus and the left side all dot. What is plus and dot? Plus the current going away from us, the dot current coming to us. Okay, and the effective current will be flowing from this side to this and this side to this. So EMF is induced and currents are produced, but the currents are equal and opposite. You can see it is flowing like this. The current will be equal and opposite. When the current is equal and opposite, the torque will be cancelled out. There will be no torque. Okay, so EMF is there, current is there, but the currents are getting cancelled each other. So there is no torque. If there is no torque, what happens? The motor will stand still. Rotor will not rotate. So we can say when the brush axis is collinear like this, the motor will not rotate. Okay. Now the next condition, which is placed perpendicular to the magnetic axis. What happens here? The brush angle it is at 90 degree. It is 90 degree to magnetic axis. Now you can see this is the brush axis on the top part and the bottom part, how the EMF is induced. You can see in the top part this is positive and in the left side it is dot. That means in the upper part there is equal positive and equal dot. So both will be cancelling each other. So EMF itself will be cancelling each other. EMF will be itself cancelling each other above the brush axis and below the brush axis. If EMF is cancelled out, what happens? When EMF is cancelled out, there will be no current. When EMF itself is cancelled, there is no current. When there is no current, there is no torque. Okay, so if the brush position is 90 degree is to the magnetic axis, there will be EMF but equal and opposite above the brush axis and below the brush axis. So the EMF cancels out each other. When EMF cancels each other, what happens? There is no current. When there is no current, there is no torque, and again the rotor will not rotate. So when we are placing the magnetic axis or brush axis perpendicular or collinear with the magnetic axis, the repulsion motor will not rotate. Now the question is how to produce torque in the repulsion motor. That is the question. That will be told in the next slide. What you are seeing here? You are seeing in the magnetic axis, but the brush angle has been given. Brush has been inclined with the angle of alpha. Now the brush has been shifted from the magnetic axis with an angle of alpha. Okay, so that is the thing. Now we will go deeper what is happening to see. N at top pole, so N available here and S at the bottom, same as the previous case, and brush it is now at alpha degree angle. Okay, and armature current is induced. How the current will be finding out? This is the brush axis. The upper part and the lower part you will be able to see dots and plus. So this is the brush axis. Here in the this part plus is available. I'll just change the color. This is the brush axis. Above the brush axis, here it is plus, and above the brush axis somewhere it is dot. So here it is dot. So in the brush axis itself there is plus and dot, but it is not equal. Dot is more, plus is less. And what about the bottom part? In the bottom part plus is more, and what about dot? Dot will be less. So you can see here the rotor is becoming a powerful magnet. You will be already seeing the rotor is having N polarity here, S polarity here. Rotor is becoming a magnet. At the same time, AB current, the current in AB, this is the area where AB is available, and AB is producing a torque like this. We can say torque in this direction, let us assume. Okay, and AB, it is the part we have seen, it is already written AB, that area anti-clockwise torque is there. Similarly CD also will be having a anti-clockwise torque like this, CD. Let us assume. What happens the other side with the green? It will be having the torque in the opposite side. Torque will be in the opposite side because the plus and dot it is different. Okay, so the green indicates the torque in one direction and red indicates torque in another direction. So red torque is less and green torque is more. Okay, so the torque is not balanced. Torques are not balanced. Red arrow torque is less and green arrow torque is more. Now you will be able to see the polarity of this item. Polarity of main winding and polarity of rotor. Already rotor is a magnet. So N and N it is very near to each other. So what happens then? Let us see. Induced motor poles it is not main poles, it is not directly near to the main poles, it is having a shift because of the brush angle. Now what happens, the poles N and N will repel, N and N will repel. Already we have seen it is in that direction the more torque is available, and it will be, the motor will be rotating in clockwise direction, because in the previous slide we have seen the green color torque is more and the similar poles are repelling now, and now the repulsion motor starts, and it is the working of repulsion motor. This is the way torque is produced by a brush shifting angle and creating what? Creating a unbalanced torque condition. Now I am asking how the direction of rotation can be changed. In repulsion motor, to change the direction of rotation, now you can see in this condition it is rotating in the clockwise. If the brush setting angle is changed to the left part like this, if this is alpha, then the direction of rotation will be in the opposite side. So to change the direction of rotation of a repulsion motor, you have to shift the brush angle position. In the practical motors available, the repulsion motor generally is attached with a lever. The lever will physically shift the position of brush setting angle. If it is put in the clockwise position, it will rotate in the clockwise position. If it is put in the negative position, it will be rotating in the negative position. Okay. And we are generally changing the brush setting angle between 0 to 45 as this. It can be actually shifted from 0 to 90 degree. Let us see what happens the brush setting angle from 0 to 90 in this diagram. The angle it is from 0 to 90, it is shifting. You can see the torque differences. The torque is going on increasing, reaching a peak value, and it is reducing at 90 degree. Again it is going to 0. Okay, so the practical values are up to 0 to 45 degree available, and a maximum torque will be occurring in the repulsion motor in this region almost near to 18 degree. Almost near to 18 degree, the repulsion motor will be having a higher torque. From this graph you can understand that. Now the features of the repulsion motor we are telling, basic repulsion motor, it is having higher starting torque, more than 3.5 the rated torque, more than about 350% of the rated torque. High starting torque is there, and starting torque it is comparatively less. Generally single phase motors having a current of 7 times the rated current. Now it is only 4 to 5 the full load value, 3 to 4 times on the full load value it is taken by the repulsion motor. So this is the advantage part. Now we are going to see the disadvantage. The speed will be very high. If the load is very high, the speed will be okay. But in the repulsion motor, if the load is reducing, it will be going for high speed. Even with no load or very light load, even with no load or light load, the speed will be becoming dangerously high. And the repulsion motor is having generally low power factor, and at high speed the power factor is improving. If the speed is very high, the power factor is generally improving. And the commutator and brushes are always connected, and hence it is having a sparking issue. Okay, the repulsion basic motor, it will be having sparking at brushes because it is continuously working the sparking at. All these problems will be improved by next improvisation, that is known as RSIR, repulsion start induction run motor. That will be discussed in the next video, how further improvements are made to the repulsion motor basic one.